Okay, so this is week 6, lesson 7. It's going to look really similar to the last lesson that we just did, in that you will have to condense. So like I'm going to condense the left-hand side of this equation because 2 logs is gross, and I would much rather it just be 1 log if possible. Okay, but the difference now is that I don't have a log on each side like I had on the last example or the last lesson that I recorded. So all I can do here is to take this out of log form and put it into exponential form, right? So this is the base, this is the exponent, and this whole thing is the answer. So now, let me move this up here. I should be able to solve this. It ends up being 3x plus 3 equals 27. And when I subtract 3 from both sides, I get 3x equals 24. And when I divide both sides by 3, I get x equals 8. And as long as that doesn't give me any negative arguments when I plug it in, that's the answer. Okay, so let's try another one. All right, so again, there's a couple logs here, which I don't like. So I would rather condense it so that I have a single log instead of 2. So I'm going to have log, because of the subtraction, I'm going to be able to condense with division. All right, now I can't set this argument over here equal to 1 because I don't have a log on the other side. All right, so what I can do instead is take this out of log form and switch it into exponential form. Now notice there isn't a base like outright written right here, which means that it's understood to be 10. Okay, so it's going to be 10 as the base raised to this exponent equal to this argument. All right, which I'm going to solve by cross multiplying. So this will be 90 equals negative 3x minus 3. When I move this negative 3 to the other side, I will have 93 equals negative 3x. And then dividing both sides by negative 3, I end up with x equals negative 31. Now, you might think, oh crap, there's a negative. It's going to make a negative argument. But check it out. When you plug that in here and you multiply it by a negative, it becomes positive, right? And it's a very large positive. And when you subtract 3, it does not make a negative argument. So this definitely is your answer. All right, scooting it up. Again, some more practicing here. Condense the left. This is going to be multiplied, so I'm going to have, what, negative 12x minus 15 equals 2. And then, again, I need to get this out of log form and put it into exponential form. So it's going to be 9 squared, which is 81, equal to this argument. Okay, I'm going to add 15 to both sides. So I now have 96 equals negative 12x. And if I divide by negative 12, I should get x equals negative 8. Now, again, sometimes that negative will cause you to, think, oh crap, this isn't a right answer. There's no solution, but let's take a look. If I plug negative 8 in here and I multiply, I get 32 minus 5, which is positive. So this definitely is the answer. All right, and then scooting it up for my last example. Condensing the left, I'm going to have the natural log of 2x plus 6 equal to 2. All right, now I need to take this out of log form and put it into exponential. And hopefully you remember, again, from previous lessons, when you have natural log, the base right here is understood to be an e, like literally the letter E. So I'm going to have e squared, right? Base, answer, exponent equals 2x plus 6. And we're trying to solve for x. You know how to solve this equation. I'm going to subtract 6. So e squared minus 6 equals 2x. And then I'm going to divide everything by 2. And since we're not using any calculators on this whole answer with the e included is what x equals.